project was to have our robot reach a light source, a flashlight, within 60 seconds. There was a starting box denoted with tape at the beginning of the obstacle course where we were to place our robot. We were then to start our robot by pressing a button attached to the bot. After pressing the button, the robot must navigate its way through the obstacle course, complete with boxes and cones in the way, and ultimately reach the flashlight and stop within 60 seconds. The ambient light mode is a mode that can be set on the color sensor. The ambient mode works by measuring the intensity of the light reflected in the sensor's receivers as a value from 0 to 100. 0 is the intensity when the ambient light is not picking up any reflected light. A value of 100 means that light is fully reflected back at the ambient light sensor. The touch sensor has a button at the end of it. When the button is touched down, the sensor equals 1. When the button is not pressed down, the sensor equals 0. We were able to code for our robot to start when we pressed down the button on the sensor, equaling 1. The ultrasonic sensor measures distances, which it displays in port view. The ultrasonic sensor is key in measuring obstacles in front of the bot, which allowed us to code for it to avoid obstacles in its path. The gyro sensor's purpose is to keep track of the robot's angle and measure the angle of rotation. It allows for movement to approach these angles. The gyro sensor had many issues, such as it had a very large drift when moving at higher speeds, and at times we completely lost track of the angle measurement that the gyro sensor was using.
Our first tests had us struggle quite a bit in making our robot avoid obstacles. Our overall strategy for it was essentially just having it avoid specifically the Lego boxes, because they were the only obstacles that we would possibly be encountering in this assignment. So our strategy was very specific to this assignment, but it was very reliable and repeatable once we had it finished. But initially we had some problems. Later on, we started to discover that there were some problems with the gyro sensor, which at times would cause it to go off in random directions. We fixed this by hard turning it on anytime we wanted to have the robot run through its program. It led it to great amounts of success when the robot was actually started up from being turned off completely. Further, we managed to have our robot be somewhat successful in our actual trials. In our actual trial, we were somewhat successful in that we had our light detection routine activate after using our motion detection routine. However, our light detection routine had the light value set as far too high for it to stop completely. So it forced the robot to keep going past where it should have stopped. Overall, we consider ourselves fairly successful in using our robot's sonar sensor and light sensor. Primarily in this task, we managed to be fairly successful in having a light detection program as well as obstacle detection and avoidance program for this specific task.